was an important one. So last class, we defined, I know, I got to put it up there.
I have a question.
Yes, what's your question? Sure.
So, you know when we use the factorial, right?
Yep.
And when we are trying to use the ratio test. So down when the factorial is there, we multiply by n factorial, right? To the entire thing.
Wait, you're going to have to say that again. So when we define factorial?
For example, this, right?
Yeah.
So when you multiply by, this will be right, right? To do like this.
Yes.
So why do you do this though? I don't get it.
What do you mean you don't get it?
So when you expand this is not what you get. But we just added an n factorial at the end.
No, but there's an n factor. What do you mean?
See, this the equation.
Hold on.
we get,
What
right?
problem is this? We'll have to look at it.
S.
We didn't do that problem, did we?
No.
Yeah. So when did I explain that then? I'm confused.
So one of the problems that we did that was similar to this, that's what you did. So there's a
Yeah, but the difference between this is a grouping. This 2n is grouped. It's not 2 times n factorial. I think what you're comparing, let me show you what I'm saying. Let me put this on the TV. I think what's confusing are so there was a question brought up about one of the homework problems in factorial. So it's probably worth our time to talk about it. So I think what the problem you're referring to, which one was this? S?
yeah.
So you're looking at, if I'm not mistaken, why is this not showing? Oh, there it is. Basically, what was it? It was 2. I don't care about the negative stuff because that goes away. What was it? 2?
It was 5 to the power 2n.
5 to the 2n over 2n quantity factorial, right?
Yeah.
So this is completely different. You have to be very careful what you're doing here. So if this is a sub n, then a sub n plus 1 is 5 to the 2n, not plus 1. Well, it depends on how you think about it. If you have to,
yeah, that's the way I did it.
right, and then downstairs, the way I would think about this is 4n, excuse me, 2n plus 2.
Yeah.
So the way I would tell you to think about this is 2n plus 2 factorial. Right, so then if you take this and divide, so a sub n plus 1 over a sub n. So to save space, I'm going to write it assuming that we're okay with this now. So if I take this and divide it by a sub n, it's the same as multiplying by the reciprocal, correct? Right, so the reciprocal of this is 2n quantity factorial over 5 to the 2n. So this simplifies differently than how we talked about the stuff before. Well, first off, yeah, the 2n's cancel. So you're left with a 25 here. Now, this, the way I would tell you to think about this is that the numerator is that, and then the denominator is, so this is 2n plus 2. Then what's the previous one? 2n plus 1. And then it's 2n factorial. So now they cancel.
So wait, 2n plus 2, and then you want to do.
Well, what comes before 2n plus 2?
2n plus 2.
Correct. So that's why I went here to here.
And then from there you want
Then what comes before 2n plus 1 is just 2n, right? So now they cancel. And so you're still going to get that this thing, which is 25, and you don't even have to multiply it out because it's degree 2. This is going to go to 0.
So I did that same thing, but I didn't get that 2n plus 1.
Well, but this is the correct way to do it. You can't use that trick. I think the trick that, not trick, the formula that you're thinking of, which is correct, but it's not applying here.
I did the same exact thing you did, right?
Yeah.
But that 2n plus 1, I did have that, but I had 2n factorial over there on the side.
Well then, but yeah, but you're okay. But see, that's the thing. But you didn't do it correctly then, right?
So I was wondering, why do you have like, so how do you put a number, like, how do you determine that what number comes with the factorial at the end? Say, let's say if there was 2n plus 3, right?
Yeah. So then, what comes before 2n plus 3?
2n plus 2.
Right.
So
And
it goes on like that. Right?
yeah, exactly. Yeah.
Okay. So if it was 1, then it just directly goes to 2n factorial.
If it was 1,
2n plus 1. Right?
yes, correct. Yeah. I mean, this is much more difficult to reason because it's grouped as 2n factorial. If it was just n factorial, it's not so difficult to reason, but you have to think outside the box here. I mean, look, this is abstract thinking. You have to recognize that n can be any positive integer. So you have to think about it. If you can't see the pattern in n, pick a specific one. Say let n be 4. Then what's 2n plus 2? Well, if n is 4, then you get 10, right? So what comes before 10? 9. Well, that's the same thing as 2 times 4 plus 1, right? Does that make sense? And then what comes before that? 8. Well, 8 is the same as 2 times 4. So that's the way that you can think about it. Does that help?
Yeah.
All right. Okay, so very good. Okay, so let us, what's that?
Very good with the figures.
Oh, yeah. All right. Good. All right, so at the end of class, we conjectured so what we did is we pondered extending a Taylor polynomial to a series. Oh my God, there goes my phone thinking I'm talking to her. What a time. And so it turns out we can do that. And so let's be very careful with how we think about this. So we can define this. But, question. Let me not say but, because that's putting the cart before the horse. So we can define this, and creatively enough, it is called the Taylor series of F centered at A. So again, this is going to look very frightening, but here we go. So what is it? You'll remember it is F evaluated at A plus F prime evaluated at A times X plus the second derivative evaluated at A over 2 times, I guess we got to be a little more careful. I'm cheating. This is not just X. This is the quantity X minus A And then this is the quantity x minus a squared. And then the third derivative evaluated at a over 3 factorial. And then that's times the quantity x minus a cubed. And then this pattern goes forever and ever and ever. Or if you want to be real cute and show your skills, you can write it in sigma notation, which will scare the heck out of almost everybody on the planet. K goes from 0 to infinity of the kth derivative evaluated at a over k factorial times x minus a to the power k. Yikes. Now, so the only difference between what we talked about yesterday and today is now you see this ellipse here. The idea is we can extend this forever and ever and ever. And of course, like we alluded to yesterday, the big question will be, how do we even know it converges? So look, here's the first thing you have to get over. This is a polynomial if we cut it off anywhere. Now, I know this thing here looks scary, but all this is a number. It's a number. Why is it a number? It's the number that you get when you take the third derivative of f, plug in some number a, and then divide it by the number 6. And of course, over here, you might say, well, why didn't you divide here? Well, again, I didn't write factorial here because 2 factorial is 2. Maybe I should have. And maybe I should write divided by 1 factorial and divided by 0 factorial. One thing that you should note, the convention that is used is note that the 0th derivative just means f. Right? So if I'm not taking any derivative, it's just the function itself. So it's kind of like a weird notation convention. But if we use it, it allows us to write this scary thing compactly. Now, if a is 0, this thing does not look as bad. For a equals 0, we have f of 0 plus f prime evaluated at 0x plus f double prime evaluated at 0 over 2x squared plus the third derivative evaluated at 0 over 3 factorial. So there's lots of pattern stuff here. And so in this case, we often give it a name. I think in math, we like to give names to people, usually weirdos and stuff like that. I don't know. But since Taylor gets this attributed to him, then one of the gentlemen who did work with these, or not necessarily just with series, but stuff in general, was this guy named Colin Maclaurin. So it's often that in this case, we call this a Maclaurin series. So we usually call this a Maclaurin series. So Taylor and Maclaurin, so let me write it like this. So Maclaurin is a special case of a Taylor series. So it's kind of like every square is a rectangle, but not every rectangle is a square. Every Maclaurin series is, in fact, a Taylor series. It's the Taylor series where we're centering it at 0. Now, here's what we already know. You guys currently know 2, technically 3. So we already know three famous, I'm going to write them as Maclaurin series, but you can also write them as Taylor series. So we'll just kill two birds with one stone and say we already know three famous ones. We know the one for E. What is e to the x's Taylor series? We already found that it's 1, or it's Maclaurin series, 1 plus x plus 1/2 x squared plus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the 5th, blah, 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 blah. And then we showed you what the signs was. The signs was x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th. And then a little bit of your own reasoning, which we'll ask you to do for homework, is show that the cosines is 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th.
For e to the x, we need 1 over 4 factorial x.
Oh yeah, I don't know why I wrote 5 there. Yeah, good point. This is not a 5. So a couple things that are important. Notice that I don't have equal signs here. I'm not saying e to the x is equal to this. Now it turns out they will be equal, but we don't know what that means yet. So right now we're just saying that these are Maclaurin series. And this is the Maclaurin series for e, this is the Maclaurin series for sine. So as we alluded to yesterday, so for which x do these or any Taylor series converge? I mean, we know not every series converges. So if you just picked some arbitrary x and plugged it in, how do we even know it's going to converge? Why would we expect it to converge? Anybody have a question, comment?
So for the geometric and the other series we learned, right? It's not that any specific value of x will convert.
That's true. I mean, if you want, consider, okay, so look, this might help answer your question. You can also, what's the Maclaurin series for 1 over 1 minus x? This is the geometric series. So what is its Maclaurin series? Well, its Maclaurin series is 1 plus x squared plus x cubed plus x to the 4th, dot, dot, dot. And so from what we know about geometric series, this only converges when x is between 1 and -1, right? Now, you might say, how do I know that's the Maclaurin series? Well, we'll ask you to do it for homework. You take that function here and differentiate it and get a pattern. You'll notice there's a pattern. It's not hard to differentiate. It's not hard to plug 0 into it. Now, it turns out, so I used this sort of metaphor before that like not every Taylor series is Maclaurin, but every Maclaurin is Taylor. So Taylor series is a class of series. And there's a more general class. And so it turns out if you want to study Taylor series, what you could do is study the more general class, and everything that the more general class has true about it, you can apply to Taylor series. And then you can apply that, of course, to Maclaurin series. So it's kind of like we're going to try to kill all these birds with one stone. And it's also what's nice about studying the more general setting is it's not as notationally ugly as the Taylor series. The Taylor series is kind of ugly. You have that F to the kth derivative over, you know, you have a lot of ugliness happening. So we could study a more general case, and we're very happy. Well, you might not be, but we will be. Does anybody have a comment, question? Okay, Maclaurin, he's an Irish mathematician who's been dead for years, Emily. Look him up. We can make you guys should do a book report on these people. That would be fun. Huh? Yeah, maybe. Could be extra credit this semester. Okay, here we go. So, give me some colors. Yo, what happened? Okay, so to answer convergence questions, about Taylor series, it's useful to study a more general series. And these are called, I should say, a more general class or type of series. And these are called power series. And this is one hell of a creative name, because you're going to see why they're called power series in a second. Guys having fun yet? Don't lie. There's only 2 people here. How many people we got online? Tell you what, attendance is suspect. There's 12 people online, one. That's 11. So there's 13. We're missing fools. This damn election over yet? Let's go see what Twitter says about the election. Well, that's what they say, but then Trump's going to sue, right? So who knows?
What they say, some of the states said that he doesn't have real evidence, so they're not going to come.
Well, obviously. But this is the thing. They've been arguing about this for weeks now, right? You know, if you like Trump, you're going to say they're cheating. It's like the same thing happened 4 years ago. 4 years ago, the Russians cheated. Now it's the Democrats that are cheating, right? So, like, you just can't win with any of these buffoons. I do find it funny. Like, no one, you know, it's interesting to me. Like, if you watch the election Tuesday night, in the beginning, Biden was smoking in Ohio. He was killing because of the way they counted the votes. Well, it turns out Trump ended up beating him, smoking him. No one cried on the Republicans when that happened, right? But yet, you know, the next morning when Michigan went and uploaded all their mail ballots and they jumped, well, all the Republicans started crying, like, how do you jump? You know, well, if you pay attention to how they do it, then it makes sense, right? So I don't know how, but I don't want to get into it, but it is funny how these people cry. The hypocrisy is so everywhere. It's palpable.
Just funny, like Trump already announced on Tuesday that he's won.
Oh, hey,
On Wednesday, it turns out
it's going to be, imagine if you thought he was crazy and didn't give a damn the last 4 years, just imagine what he's going to be like in the next 3 months. It's going to be a poop show, if you know what I mean. It might be an enjoyable one. Well, you want that? I mean, they use machines to count the votes, but that's the other thing that's hysterical. Like, the fact that like people literally believed that like every vote was counted by like 8 o'clock on Tuesday night. This is how stupid people are. And I don't mean to say that. But like you understand that the amount of votes that there are, it is physically, arithmetically impossible to count them all in a reasonable amount of time. What normally happens though is when it's not close, you realize, hey, there's X amount of votes left to be counted, but the difference is bigger than X. They'll never catch up. This person wins, right? So but this isn't, we knew it was going to be close. And yeah, well, Nevada does, Emily. Nevada does. Nevada's just taking their good old time.
They started comparing it with Internet Explorer.
Yeah. But, well, the problem is Nevada, I mean, I don't know how the states decide how they're going to count votes, but even Pennsylvania said to the votes they're counting now were all ballots that they got long before Tuesday, right? So it's not like, and I'm sure you can verify that. Everybody's making a kill. You don't think the news networks eating this is like 4 nights of people watching the news. They're loving it, right? This is just like.
At the point, I think like they delayed it, but they didn't want the stock market to crash.
I don't know, man. Maybe there's always that, but I mean,
They released it to the stock market would be close to the weekend.
I mean, think about how they cover the election. They cover it like it's a damn sporting event, right? If it like it's so fascinating. It's advertising. Like I don't want to pretend that the corona is fake because I don't believe it. I think it's a serious thing. But don't think for a second the news networks aren't loving it because they got you paying attention every damn day. Imagine for months after March, I mean, people were glued to their TV. How many people are going to die today, right? Like it's like, and it sounds terrible. It's like when there's a terrible event like a hurricane. When Hurricane Katrina hit New Orleans, 15 years ago or whatever, the news was eating that up because everybody wanted to watch. Oh, of course, Eric, but they're not allowed to. The irony is in Pennsylvania, they wanted to, and the Republicans said no. So it is funny, though. I saw that. I don't know if you saw the video clip of, some of you probably love Bernie Sanders, the crazy man, but that clip of him like a week ago predicting all this happening. He's like, here's what's going to happen because they won't let us count early. Trump's going to be winning Tuesday. Then when all the mail-in ballots come, which are going to be even historically are high Democratic numbers, and then they're going to claim that we cheated. Like I said, if they cheat, you got to have evidence, right? I guess. I don't know. Maybe the Republicans will spend 3 years trying to prove that the Democrats cheated, like the Democrats tried to prove for 3 years that Russia cheated 4 years. Russia's just back there. What do they say? Cracking a blunt. Crack. Nah, I shouldn't say that. What's that?
It didn't affect Russia at all.
Nah. I mean, I don't think it really newsreel. I don't know how much it affects anybody, really. I mean, most of the things that affect your daily life aren't done by the president. They're done by the local. I mean, think about this. If everything holds the way it is, the Senate is still Republican, which means if you think that like Biden's going to just get rid of your student loans tomorrow, that ain't happening no sooner than Trump's wall is going to be built and paid for by Mexico, right? Like it's just not happening. So it'll be, although, probably that's good for the stock market because it's the checks and balances as my friends and I discuss. Yeah. Well, that's why they make the government the way they do. So one lunatic can't do whatever they want. Anyhow, the Vadians are the cacti. They might be. I saw they were interviewing PA's lieutenant governor, the guy from Braddock. I like him. He's a big dude. He makes me laugh. But they were like, is there any voter fraud? He's like, yes, a Republican tried to vote for their dead grandma. So, there you go. These people, oh my God. Yeah, but I think the Nevada issue is they weren't allowed to count the mail-in ballots. And so everybody who lives in like Clark County, which is Las Vegas, they all did mail-in ballots. And that's predominantly Democratic, at least, historically. So those ballots are still waiting to be counted. So yeah, you're right. There's like 2 places in Nevada where there's more than 5 people. They happen to be Nevada, they happen to be Reno, and they happen to be Las Vegas. But if you've paid attention to anything about politics, what you'll notice is anywhere there are cities, it is almost predominantly Democrat. And when it's rural, it's very much predominantly red. I mean, you could look at Pennsylvania's map. It's blue, 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 red.
Trump told his supporters not to vote in early.
Well, he did. That was a mistake on his part, I think. So we'll see. Sometimes you're better just to shut up than to say anything at all. But yeah, but usually that's all that most states have, Emily. Yeah. Not even a lot of blue states. I mean, if you look at places like California, it's a lot of blue, but there's a lot of red. But the places where it's blue are way more people. Look at Georgia. Georgia's almost all red except for one place, the ATL. And that's just the way it is. And if you think about it, this is good thinking to talk about. If you think about it, if you grow up in a rural place, your perspectives of what are important and that you care about and would affect your family are completely different than someone who lives in a city, right? Like, for example, if you live in a city, you are much more dependent on the people that are around you. You're much more dependent on public services. You're much more, if you live in the rural areas, you don't give a damn about paying for ambulances or school buses. You don't care about plumbers. You're doing everything yourself, right? So it's a different world. It's a different idea of what's important to you. So I don't think most people think that. Everybody wants everybody to think the way they do. And that's kind of dumb, especially when you live in a state with, how many people live in Pennsylvania? 10 million people? I don't know. Hell, I mean, should the whole state of New York be run because there's 20 million people in Manhattan? I don't know. It's a weird way that we do things, but it ain't all that bad. Everybody will go back to, 4 years ago, I'm generalizing and making broad generalizations, but all the hippies and all the liberals cried for weeks after the election, right? And then this year, all the dudes running around with machine guns will cry for a few weeks after the election, and then we'll be back to normal in a few months. What's that?
Like, that's always the case.
I know.
In Kenya too. They fought for like 1 week, 2 weeks, then everything was back.
Yeah. Yes, Muhammad's well, legally, yes, once someone hits 270, but you have to, typically what happens in normal times is whoever wins sits there and waits, and whoever loses says, hey, congratulations, good for you. But that's not going to happen this time. Trump's going to try to sue the hell out of this. And maybe there is something they'll find, although there's no evidence to suggest there is now. I found it funny yesterday. Trump's bitching about them counting in Arizona, but he was losing in Arizona. So if they stop counting in Arizona, he automatically loses. I said, this doesn't make any sense to me. Then again, most people don't understand arithmetic, as I have to learn when I try to teach you guys things. I'm like, come on. Well, don't think for a second. They're not going to go back. You know how many lawyers, how much money is going to be behind the Democrats? I mean, these people all got money. They ain't worried about it. And plus, I'm pretty sure a lot of the stuff they already tried. Yeah, they already tried going to the Supreme Court, and the Supreme Court told them a couple of weeks ago, shut the hell up. Yeah, the states are like, get out of here. It is, yeah, right. At least have evidence. Like I saw yesterday, there's all these right-wing people were posting this video of this couple, not couple, but a man and a woman reading vote. You could see one, and it looks like they're cheating, and they're like, no, this is how they fix ballots that aren't scanned. So there's the ballots that aren't scanned, they have to make sure that they're correct, right? So it's there's no doubt there's probably been voter fraud before. Let's not fool ourselves, right? But to act like Georgia, Pennsylvania, Nevada, and Arizona all decided to have this big cheating scheme all of a sudden that no one would figure out, it seems kind of far-fetched, right? Yeah. I mean, God forbid the obvious thing that a lot of people who voted because it was easy to put something in the mailbox than to catch a bus and go to a voting center or wait in line, all those things, it's just it's hysterical. Well, he can try to sue all he wants. So you have to have. I was listening. Who the hell was I listening to last night? It was actually one of the Republican people, and they're like, I don't know what he's talking about. He can't just sue because he wants to. You don't get to go to trial because you think something happened. I don't know. It is funny though. What a time to be alive. All right, let's get back to math. This is good. Too bad we should have taken a whole week off and just talked about politics. That's what we should have done. It would have been great. We could do the math of gambling and stuff, or not gambling, but of politics, gerrymandering and all that stuff. It happens. I wonder how they decide. An interesting thing to me is who decides, I guess it's probably the case that most of the mail-in votes came from urban areas. That would make sense to me. For one, like voting in a crowded city ain't the same as voting for you in your little nice little pad and 40 minutes outside of the city. You just go down, there's 3 people at your place. But a lot of places in the city, you stand in line. I waited 50 minutes to vote Tuesday morning. Does my 80-year-old aunt want to do that? I don't think so, right? Much easier for her to mail her crap in. Anyhow, whatever happens, happens. I'm sure it'll be fun to watch. All right. Here we go. What's a power series? We got to get into this before we get out of here because we only have about 10 minutes left. But I like to talk about life with you guys. It's good to do that, right? You should all be aware of the world around you. So here's a power series. So a series. Oh my! Shut up, phone. How does she continually hear that? So a series of the form, watch how we write this, c sub 0 plus c sub 1 times x plus c sub 2 times x squared. I know this looks scary. Plus c sub 3 times x cubed. And this pattern continues. This is called a power series. And if you want to be specific, we can call it centered at 0. So why do we call this a power series? This is one thing that you just need. Don't get worked up over this. The numbers C0, C1, C2, etc. These are called, as you've called them before since you were in algebra class, these are called coefficients. What's that? What do you mean it's always the same? I don't know what you mean. I don't know what you're.
Let's say C sub 0 is 1, right?
Yeah.
C sub 1 will also be 1.
No, these can all be different.
Okay.
No, I mean, look. I mean, in all we're saying now is instead of having specific numbers like we did for the Taylor series, we're saying this can be a number, this can be a number, this can be a number, this can be a number. So, for example, if C sub k equals f of k evaluated at 0 over k factorial, we have a Taylor series. Does that make sense? So a Taylor series is a special case of power series. The way to think about a power series is it's an infinite polynomial. It's a polynomial with infinite degree. If I just I can't put my hand over the board, but if you just ignore everything to the right of here, if you cover this up, then you have a quadratic. And then if you cover up over here, you have a cubic. So I don't want to write A, B, C, D because I don't know how many there are, right? In fact, it goes on forever. So it's C sub 0, C sub 1, C sub 2, C sub 3. The pattern here, maybe it's this pattern or maybe it's not. There could be lots and lots of different patterns. So a Taylor series is one pattern and a Taylor series is a specific type of power series. So let's write that down because I can't emphasize that enough. So a Taylor series is a specific type of power series. So again, it's like the rectangle and square metaphor analogy. Every Taylor series is a power series, but not every power series is a Taylor series.
It's like the different rules for differentiation, like chain rule and stuff. So Taylor series is one of them.
What do you mean rules? There's no rules. We're defining something right now. I'm not sure what you mean.
No, but it's a specific type of differentiation.
Okay, so no, again, I think you're thinking of it wrong. A power series is a thing. We're saying if you look like this, if you are a number plus a number times x, plus a number times x squared, plus a number times x cubed, so on and so forth, you are called a power series. Now, what we're saying is if these numbers have a specific pattern, namely they follow this, then it's not just any power series, it's called a Taylor series. Just like if you are a rectangle and your sides all have the same length, you're still a rectangle, but we give you a special name called a square. It's a branch? Yeah, that's right. You could think of it as the family tree, right? If you want to think about a family tree, there's power series that aren't Taylor series, right? So maybe it's worth pointing that out. So so one way to think about it is this. Let's give you an example. Is
How many power series are there?
how many?
Yeah.
There's infinitely many.
But like the specific ones that we're going to learn during this time or the next class that we're going to.
I mean, specific ones?
Yeah.
I mean, there's going to be a few that you're going to, there's going to be a few that you need to know, like the ones we've already written down. So for example, so not every power series is a Taylor series. So, you know, you'd have to do some work to verify that, but you can construct examples that aren't. So if I go back to the previous page, if my constants C aren't of this form, then it's not a power series. So you don't want to think you don't want to think necessarily that, you know, don't overthink it, Rob, but you don't want to think the power series and Taylor series are the same thing. These ideas can be studied in more general settings too, which we don't do in this class. Does anybody have a question, comment? So maybe I should be, okay, let me be more careful. I shouldn't say it this way because if one of you shows your notes to someone who's an expert, they'll say he's sort of lying. So let's not say, I don't want to get into specifics, but let's not say that because I'd be sort of lying to you. But for now, the best way to think about it is, that we're studying a much more general idea. We're not just studying this specific pattern, we're studying these can be any numbers. So maybe this is a good place to end because we're out of time anyhow. So, but yeah, I don't want to say something that's you know factually not true. So we'll end there, and we will pick up on Tuesday. So by the way, look out this weekend for a short quiz. It won't be a long one. It'll be like 10 minutes tops, 15 minutes. And then some homework to practice this stuff. All right, if you have any questions, let me know. Otherwise, have a great weekend. I will talk to you guys later. Take care. And watch the news, I guess. Thanks, guys. Have a good weekend.